Hello, future engineers, and welcome to day 2 of Fluid Power and day 2 of e-learning. Today we are going to be going over liquid flow. So liquid flow is the flow rate of the volume of fluid that moves through a system in a given time. The flow velocity is the distance that the fluid travels through the system in a given period of time. So we need velocity and area. So essentially what this formula is looking for is what size of water or fluid or solution is moving through our system all the way to wherever it needs to go and how fast it is moving. So we have some different variables in here. We have Q for our flow rate, which is a very similar variable to our heat transfer or the rate of heat transfer that we had in thermodynamics. Remember, we use Q. And then V is for velocity, A area. One thing to note is that the flow rate can be measured in either gallons per minute or inches cubed per minute. Very different. And then same thing with flow velocity. We can have feet per second or inches per minute. So we have some different variables and we might need to do some conversions down the line. So let's go on to our first practice problem. All right, liquid flow practice problem 1. A flow meter is attached to a hydraulic line that measures 40 gallons. The line has an inside diameter of 2.5 inches. Calculate the flow rate of the flow meter. So our unknowns are the area of the hydraulic line, the flow rate, and the flow velocity. So let's solve for the area first. We're going to solve for the area of the hydraulic line. We are once again given our diameter, so we can just throw that into our area of a circle equation, which is pi times the radius, so 1.25 squared. That is going to give our area as 4.91. So we have 4.91. Now we are looking for the flow velocity. So let's find flow velocity. And we're going to solve for the flow rate first. We need our flow rate because we can find velocity if we have Q and we have A. Right now we just have A and we kind of have Q. We have Q at 40 gallons per minute, but we need to make a conversion over here. So every gallon equals 231. So we're going to do 40 times 231, and we will find Q to equal 9,240, and this is inches cubed per minute. And now we can take that Q and put it into our flow rate calculation over here. So we've got 9,240 as Q is equal to unknown velocity times 4.91. So I'll divide both sides by 4.91. We find that our velocity, put it over here, V is equal to 1,882, oh boy, .37 inches per minute. All right, so we have found our velocity, we have our area, and we have our Q. Cool. So we were able to discover that using our area formula and throwing everything back in here. All right. So that was our very first practice problem. Now, what you have to do for your assignment today is liquid flow practice problem number 2. Very similar problem, but you will have to incorporate Pascal's law into here. So we are looking for the diameter of the hydraulic line and the flow rate. So once again, we don't have the diameter given to us of the hydraulic line. We don't have the area either, but we do have force and we do have pressure. So we can find our area in the equation. And that's how I'd recommend getting started. So for today, try your best at practice problem 2. I will post the solution later today. Have a good day.